Hey everyone, welcome to this explainer. Look, I want you to completely forget everything you think you know about standard commercial vehicles. Today, we're tearing down the illusion that sanitation vehicles are just regular freight trucks with a different paint job. These are highly specialized, industrial beasts, operating in some of the most brutal, relentless conditions imaginable. If you're a focused learner looking to truly grasp how to keep these machines alive, you are in exactly the right place.
Okay, let's dive right into this. Here's our roadmap for today. We're going to cover 1. The extreme operational environment. 2. Critical systems under stress. 3. Application-specific asset care. 4. Procurement and preventative workflows. And finally, 5. The future, electric sanitation. All right, Section 1, the extreme operational environment. We really need to treat these vehicles as specialized machines battling some intense physics and chemistry.
If we want to master fleet uptime in this sector, we've got to stop treating these trucks like standard highway tractors. Think about it. A regular freight truck, it enjoys steady-state operation on nicely paved roads, right? It has predictable mileage-based maintenance. But a sanitation vehicle is a whole different animal. Its everyday reality is severe torsional frame stress from shifting heavy payloads, brutal stop-and-go routing, and literally continuous mechanical torture. It's a completely different operational universe.
And you know, it's not just the physical stress either. The environment itself is actively attacking the truck. Garbage compactors handle highly acidic organic leachate every single day. Water sprinkler and vacuum trucks are constantly processing abrasive, debris-filled fluids. All these harsh substances act like a giant accelerant for corrosion right across the frame rails, the air lines, and those vital electrical harnesses.
Moving on to Section 2, critical systems under stress. Let's look under the hood at where the most catastrophic damage actually happens. So, now that we understand the brutal environment these things live in, we have to look at the truck's vital organs. And we'll start with the PTO, or power takeoff. Basically, this is a specialized unit that engages frequently just to divert engine torque to drive those massive hydraulic pumps. It's what does all the heavy lifting. But because of this constant high-load engagement, it creates really unique, localized wear patterns on the engine block and the transmission gearing. Patterns that frankly differ wildly from anything you'd ever see in standard freight transport. Now, what's really interesting about this is how every specific stressor demands a targeted preventative solution. Take hydraulics. Because they face high-pressure PTO cycles, you absolutely need rigorous hose checks and frequent filter swaps. And since the drivetrain suffers from high idle, stop-and-go routing, things like U-joint greasing and checking transmission temps become vital. That corrosive leachate we talked about, it relentlessly attacks the structure, making daily frame washing basically non-negotiable. And finally, to fight off moisture and vibration, your electrical harnesses demand extremely tight sealing. Let's detail some of the visceral damage caused to those hydraulics and brakes. For hydraulics, you absolutely have to have 10-micron filtration because even tiny debris will just chew up and destroy sensitive pump internals. If you neglect your hydraulic oil temperatures, you're going to trigger fluid cavitation. Over on the braking side, those start and stop roots cause rapid lining destruction and extreme thermal cycling on the foundation brakes. Even more critically, if you don't drain the moisture from the air tanks daily, and I mean daily, that accumulated water is going to rust the internal pneumatic valves. That leads to complete, highly dangerous brake lockups. No way around it. And the truck's brain isn't safe either. Unprotected CAN bus networks, modern proximity sensors, microswitches, they all degrade incredibly fast in these corrosive environments. This moisture ingress causes totally erratic equipment behavior and unpredictable safety lockouts. It can completely paralyze the truck mid-route and destroy your entire daily schedule. That brings us to Section 3, Application-Specific Asset Care. See, not all sanitation bodies are created equal. They're essentially different species of trucks, and they have entirely unique mechanical vulnerabilities based strictly on their payload. Take refuse compactors, for instance. They rely on these incredibly heavy steel packer blades guided by friction-worn polymer slider shoes. Technicians have to proactively replace these polymer wear pads before the structural steel makes direct, catastrophic contact. Plus, the vulnerable chrome rod seals on the hydraulic rams, those require daily debris clearing to prevent deep, irreversible scoring. Then you have sweepers and water trucks. These guys operate in severe, high-dust environments. Because of that, engine air intake filtration instantly becomes your top operational priority. For the water pumps, frequent mechanical seal inspections are critical. Actually, let me be very clear here. Operating a high-pressure water pump dry guarantees the instant destruction of the internal bronze or stainless steel impellers, literally instant. And what about vacuum sewage suction trucks? These units utilize powerful vacuum systems, relying on liquid ring or rotary vane pumps. Maintenance here focuses super heavily on the primary and secondary shutoff valves inside the tank. Consider this a severe warning. If these internal safety valves fail, raw sewage liquid will bypass containment and permanently destroy those incredibly expensive vacuum pumps. Talk about a bad day.
All right, Section 4, Procurement and Preventative Workflows. We've diagnosed the problems, so let's prescribe the solutions.
Believe it or not, effective fleet maintenance actually begins before the truck is even built, right during procurement. You absolutely must align your chassis brand, whether you're looking at Sino-Truck, Dongfeng, or Shakman, with the exact payload size and hydraulic requirements. Selecting an undersized chassis, whether it's a standard 4x2 or a massive 8x8 setup for a heavy-duty route, that guarantees premature component failure right out of the gate.
So the crucial point is this golden rule in the sector. Engine hours and PTO cycles always override odometer readings. Let the gravity of that vocational fleet management paradigm sink in for a second. A truck might have low miles, sure, but if it has spent thousands of hours in high-idle PTO operation, its internal components have endured a literal lifetime of wear. To combat this wear, you really need an actionable, preventative rule of 3. Step 1 is daily operational checks. This means physically checking hose routing, ensuring PTO smoothness, draining those air tanks, and washing down corrosive areas. Step 2. Weekly lubrication routing. Technicians must grease all pivot points, packer blade tracks, and U-joints to displace water and prevent metal-on-metal galling. And Step 3 is monthly fluid analysis. Extracting oil samples from the engine, transmission, and hydraulic reservoir to monitor for high metal particulate counts. This is how you predict impending mechanical failures before they happen. And hey, we also cannot forget the exhaust system on modern diesels. The start and stop low-speed driving profile of sanitation routes actively prevents passive diesel particulate filter, or DPF, regeneration. Because of this, active soot load monitoring is absolutely vital, and technicians actually have to force manual active regenerations to avoid permanent exhaust system clogs. Finally, Section 5, the future, FAQs, and electric sanitation. Let's bridge the gap between current maintenance struggles and future industry shifts. Let's hit a few rapid-fire questions. First up, what is the most critical fluid in a refuse compactor truck? Well, the answer is hydraulic fluid, specifically fluid that meets the ISO 1158 standard. It is the absolute lifeblood of the compaction body. If it suffers thermal degradation, you're looking at sluggish operation, excessive heat buildup, and ultimately premature pump failure. Next question, can electric sanitation trucks actually reduce maintenance costs? And this brilliantly illustrates the path forward because yes, they absolutely can. Going electric fundamentally changes the entire maintenance equation. Just think about the contrast here. Traditional diesel sanitation requires constant engine upkeep, managing those frustrating DPF issues we just talked about, and dealing with severe multi-speed transmission wear. Pure electric sanitation just eliminates all of those traditional diesel headaches. But keep in mind it trades them for new preventative requirements, specifically the strict monitoring of high-voltage battery thermal management systems. It's a massive shift in how we manage fleet uptime. So, as we wrap up this explainer, I want to leave you with one final provocative question to apply to your own operations. Will your fleet operations evolve to master the electric era, or will they remain stuck battling diesel downtime? Thanks for joining me.